Hello and welcome to the last PHP lecture. We have few loose ends we need to tie up, so this is like a summary of everything that didn't fit to any other lecture. Let's get started with SPL, Standard PHP Library. This is like only slide to pique your interest, because I'm not going through all the technical details through the whole reference. I just want to mention that there is a standard library. You might want to check this out. First part I would like to point out is the part with the data structures. In PHP we have arrays and objects basically, and we can use arrays mostly for anything. We can use arrays as lists, as queues, pretty much as anything we need, as hash tables. However, sometimes it might be tedious and error prone to do so, to implement everything on your own. So it might be better to use a predefined data structure which has a single purpose. It makes the code much more readable and much more comprehensible, and furthermore it is less likely that you will make a mistake when you use one of these predefined structures. Another thing present in SPL library is a set of iterators. Iterators are particularly useful because they can be used instead of arrays inside, for instance, for each loops, so you can directly use them as iterable structures, but they do not need to construct or keep all their contents in memory. For instance, if we take this directory iterator, it can give you all the entries within all the file and subdirectory entries from within one directory, but it does not necessarily need to keep all this data in memory all the time, so you can iterate over this data continuously. Another thing is regards SPL functions. I would like to point out two SPL functions which are related to data structures: SPL object hash and object ID. These two functions give you a unique identification of object, which is particularly useful if you need to place objects into hash maps or into other structures. If you are creating more complex data structures than available, then you can use these to identify existing objects manually. There is a small pitfall: the unique identification is only valid as long as the object lives. So once an object is destructed, once the object is garbage collected, then this identification, both the hash or the ID, may be reused for other objects. There are a few other things in SPL library. I suggest you check them on your own. There are a few useful links in the notes beneath the slides. Beside the regular libraries and specifications for PHP language, there are also some recommendations you should be aware of. There is this FIG group which kind of shields all the recommendation, take the review process of all new recommendations, etc. And these recommendations regard everything beyond regular language, meaning they cover things like coding styles, recommended interfaces for various common tasks, and things like these. I would like to start with something you should already know, and that thing is autoloading. Autoloading is a mechanism that should be used in libraries. It's automatical loading of classes based on their names. Just to revise the mechanism, the old way how to deal with autoloading is to override global function autoload and place your loading code in here. Modern and better way how to deal with this is to use SPL autoload register function, which is provided a lambda handler, a callback handler, which is invoked every time autoload needs to take place. The benefit of the second approach is that we can place multiple callbacks here, and these callbacks are invoked in chain, so it's kind of a chain of responsibility design pattern. The principle of this function, actually of both these functions, of both these mechanisms, is that whenever a class is to be used, for instance, to create a new object, and that class does not exist yet in the namespace of classes, then autoload is invoked with the proper class name, and this code should ensure loading, including appropriate file. So for instance, if we have a convention that every class name is bundled in its own file, which has the same name as the class, only with the PHP extension, the very simple code that would accomplish this would look something like this. So it will check that the file with the class name exists, and if it does, it will include the file. Otherwise it will trigger or log some sort of error. So the PSR recommendation actually defines how the namespaces and classes should be matched to directories and their respective files where the actual classes reside. Actually, the simplest approach that comes to mind is that namespaces should be treated somewhat like directories, and actually classes are bases for file names. You should only append something like a PHP extension or probably some suffix for these. So basically, if I have something like a class which name is over here, so the first two parts are part of the namespace, and this is the name of the class, then within, of course, some library root directory, we will find the actual file for this class as placing the whole part, actually the whole qualified name, as the prefix. Only the PHP extension is attached to the actual path. Of course, the whole specification, the whole auto-loading convention is somewhat more complicated than this. However, it's based on this general idea, so that's enough for presentation. If you'd like to read it on your own, there is a link beneath the slide. Before we get to more recommendations, I would like to revise one thing which actually is very important, but I haven't chance to fit it into any other lecture, and that's handling errors and exceptions in PHP. Before we started, I would like to revise errors. First of all, there are things like user errors. User error is actually something like filling a wrong input into a form or performing an invalid operation. Ideally, normally, these types of errors should be a part of normal, regular operations of your application. So you should count with these errors, you should take these errors in account, and you should provide sufficient remedy, offer sufficient action to the user to correct these errors. Then there are temporary errors, like let's say, for instance, missing database connection, which could be caused by the fact that the server where the DBMS runs is actually restarting or something like that. So in these cases, it's sufficient to show things like try again later message. It's a good idea to notify the administrator, because it also can mean that this temporary error requires some action of the administrator of the application. However, these errors does not need very serious handling. Then there are hard errors. Actually, these are mostly caused by bugs in your code, and these errors require special attention. First of all, you need to handle these errors correctly at the client side, meaning you should provide a sufficient generic message that will calm down the user, actually not escalate the problems. So something like error occurred and the administrator has been notified. It's a good idea not to provide any detailed information unless it's absolutely necessary, like dumping the SQL command that actually caused the bug, or putting all the log traces in the result so the user can read them. And the novice users, which are not aware of the programming languages, would be only confused with these errors, and furthermore, such let's say information leak could be misused for some security attacks. So it's not a good idea to volunteer too many information to the actual user. On the other hand, all the relevant information should be logged into the internal log, and the administrator of the application should be notified. By logging everything, I mean you need really to log every detail of the error, because the error occurs to some user who's actually provided all the necessary inputs, all the data, the URL, etc. So you need to log the position in the code, preferably with stack traces and variable dumps if possible, and you need to record all the things related to the HTTP protocol, meaning the URL if there were any post bodies, post data in the body, etc., etc., including, don't forget, the session data, because the session data might affect the error as well. Sometimes it might be helpful to allow the user to provide some comments. For instance, ask the user what was the intended action he or she was trying to accomplish, because sometimes you might not think about some special operations that the user actually wants, but they are not implemented correctly. PHP actually recognizes two types of errors. First, there are old type of errors which are in the PHP from the very beginning, and these errors are typically generated by syntax problems, syntax issues, of course, and semantic issues, and by old functions in PHP. Each error has a severity level. These are a few examples of severity levels. So the most important is a fatal error, which is the highest severity level. In these cases, if error occurs, it immediately terminates the script. So it's also one way how to end the script. Also, the default handlers typically print these errors out to the standard output. So in the debugging mode, it might be very useful. So you can immediately read the error in the output HTML. However, in production code, it's not recommended, because spitting out these errors into HTML is not desirable when the HTML goes to the end user. You can actually affect which errors are being displayed, which errors are being reported automatically, either in the configuration or manually calling appropriate functions. And you can also alter the format or anything related to these errors by PHP internal functions. You can also trigger these errors, but only user level errors. These are these errors, so you can trigger some errors on your own if you like, and later handle them. Regarding these errors, there is one special operator called a silence operator. It's represented by a @ symbol, and this symbol can be prepended to any expression. If it is, all error messages from this expression are actually being ignored, are being silenced. So, for instance, if I do something like this, if I call a file function which loads an entire data file line by line into an array of strings, and I prepend a silence operator as a prefix, then this whole expression will actually be silenced for errors, meaning that if the data file doesn't exist, for instance, no error will be shown to the output, but of course this whole expression will return false. So this trailer of this expression will actually cause the script to end with any other error. Actually, this kind of code is considered to be obsolete. It's highly irregular to use such type of code. So instead of these types of errors, you should be using exceptions. Furthermore, it's somewhat awkward to silence errors in many cases, so silencing errors is not recommended. There is one other issue I'd like to point out here. Against the silence operator, there is a scream configuration that can be set in the PHP config. So if a scream option is set in the configuration, or silence operators are void, meaning the errors will be screamed out and no silence operator can actually silence them. So it's very strange to use silence operator nowadays. I'm just pointing them out for the compatibility reasons, but in the future code you shouldn't probably use these types of operators. Finally, if you need to handle some detailed information regarding errors, it would be very helpful to get the backtrace. You can either retrieve the backtrace or even directly print it to the output, because the backtrace is one of the most important things you need to log, you need to save when handling errors. The second type of errors are exceptions. Actually, there are no surprises here. Exceptions are handled pretty much the same as in any other object-oriented language like Java or C#. So exception is basically a class, meaning the thrown exception is an object, and we have standard mechanisms like throw to throw a new exception and try-catch blocks for handling the exceptions. Exceptions should be now used for reporting all errors because they are much more convenient than regular errors. More preferably, they can be easily catched and rethrown, and also they are very useful for handling deeply nested code because they are automatically closing all the related function calls or the related blocks upwards to the nearest try-catch block. There are a few other rules you should be aware of. First of all, uncaught exception causes fatal error, meaning when the thrown exception actually bubbles up to the top level code and there is no try-catch handler there, then it will cause a fatal error, meaning it terminates the script. Second, destructors should not throw exceptions. That's pretty much obvious because sometimes such exceptions could not be handled properly because the destructors are invoked when the objects are actually garbage collected, which can be at the end of the script where are no exception handlers. And finally, throwing and catching process of exceptions is somewhat slow, so this should be used only to report serious errors, not to test some conditions or to report soft errors, because throwing the exception can cause a severe performance overhead if used frequently in the code. As I said, the concept of exceptions is pretty much the same as in other languages, so you should recognize the code. The try-catch block can be created very similarly. We can have multiple catch blocks, and the actual catch condition is distinguished by the type of the exception. So you may note that the catch expression actually expects a type hint for this particular variable, and actually in this case the type hints are somewhat mandatory. There are some predefined exceptions, so you don't have to throw the basic exception class, but there are some exception classes in SP library for common cases. I think these cover like 95, maybe 99% of normal situations. However, sometimes you might want to create your own custom exceptions. The typical reason is when you need to distinguish a specific error type, so you have some very specific error type that needs to be distinguished from every other type, or you need to handle some additional payload within the exception objects. You need to provide some room for additional data in the exception. And deriving exceptions is very simple. There are only a few rules, so you basically derive it from the exception or perhaps from one of the SPL exception classes. And when you do, actually you don't have to override anything. If you do not override any methods, anything in the class, then you can use it only to distinguish a new error type. However, if you need to modify the class further, don't forget, if you provide the constructor, you must invoke the parent constructor as well. This is crucial, otherwise the exceptions won't work properly. And sometimes it's recommended also to redefine toString magic method, because this can be used in some cases to dump the exception into the HTML or into the error logs. Speaking of error logs, all the errors and other troubles should be logged. Sometimes it's wise to keep other types of logs. For instance, keep all the user, or at least all the important user actions, logged. When we need to ensure logging, it's a good idea to use some sort of component for this. Actually, there are many ways how to implement logging components. However, be advised that there is a standard PSR recommendation for the logging. It does not actually define how the logger should work. It only defines the logger interface. Then many different types of logs, for instance, log that saves the messages into a file, into a database, or send them via emails, can be implemented over this interface. So that covers error handling and logging, and we move on to another topic, and that's caching. Caching is a generic concept for reducing computations and I/O operations by keeping the results or the loaded data in memory. In case of PHP and handling HTTP requests, caching has somewhat limited application, since every PHP process is started from the scratch when handling different HTTP requests, so only a few things can be cached efficiently in memory. This goes namely for the database operations, because the database is probably the most seriously utilized resource in PHP, so we can cache results from the database to avoid repetitive SQL queries for the same data. Also, this should be handled using some framework or API. Typically, when we are dealing with databases, we are using some sort of ORM framework, or at least some intermediate layer, and this layer or this framework should be responsible for caching. It can do also inverse caching, meaning it can aggregate update operations so that every modification, every write operation is not directly translated into a SQL command, but the operations, the updates or the inserts are aggregated together and then written to the database in one single transaction. For the caching purposes, the PSR defines caching interface. Again, this is only interface which has many applications, can be used for many different things, but it will cover all things related to caching, so it's very universal. Basically, all the items are identified by generic string keys, and it has support for details like time to live or expiration, also for deferred updates, which can be useful for the database updates, etc. etc. This caching mechanism can be used both for in-memory and both for persistent caches, which might be even more useful in the case of PHP. In the realm of PHP web applications, there is a very specific application for caching, and that is caching of generated PHP code. A typical example would be if we have a sophisticated templating system for generating HTML code, then processing these templates would require potentially a lot of computational time, so we have to process these templates using string functions, regular expressions, etc. However, PHP offers us inline HTML code, so we can inline PHP inside HTML template, which is much faster than processing our specific templates manually. So we can choose both. We can have this sophisticated templating system, which is then translated into a PHP HTML interleaved code, and this code is being cached. For these purposes, there are several things how to generate code. Basically, code generation is somewhat like inverse reflection. So unlike in reflection, we are creating the code from the scratch, and afterwards we serialize the code into the data file, actually into a PHP file. A good example would be a Nete PHP generator, which uses this generated code for the exact purpose as the example I said at the beginning of this slide. So Nete uses this mainly for generating HTML interleaved templates, whilst the original templates are in LaTeX format, which is rather specific and slightly more difficult to process. There are also other approaches. For instance, there is this PCL package, AST package extension, which allows you to directly interface with PHP low-level representation. Remember, since PHP 7, PHP uses AST trees to represent the code. Those of you who are familiar with compiler techniques know that this is a intermediate representation for code. So this is how PHP actually does handles the code and its interpretation. Remember, before in PHP 5 the code was interpreted directly from its lexical structure, so it was rather slow. This AST form is much faster, and also this is a necessary intermediate step for JITting. So in PHP 8 the authors of PHP promised us that the compiler will actually JIT the AST tree directly into the instructions of the processor. Nevertheless, this is another package that can allow you to inspect and generate code. However, this may be for slightly different purposes, for very low level purposes than simply generating templates. Also, there are some other applications like optimizations. Another example would be when we need to process some documentary comments for, let's say, code validation or input validation. Then we can pre-process this data from the documentary comments and generate PHP code that actually performs the validation itself, which would be much faster than reprocessing all the documentary comments every time this validation needs to be performed. Few more things missing, so now let's move to the coding style specifications. Actually, there are 3 PSRs that related to coding style. PSR 1, which provides, let's say, the basic overview of coding style. Then there was PSR 2, which was recently replaced with PSR 12, that defines how the code should be formatted in PHP. You may know that there are many rules. Actually, this is just an example because the list of the rules is rather extensive, but just to get you started, remember there should be normally there should be one namespace defined per each PHP file. The curly braces should start on a new line for the most of the data structures like classes, methods or functions, but curly braces should be on the same line as the statement. If you are just opening a statement block, you should place spaces around operators. You should use for-space indentation, etc., etc. I think these rules cover, the example on this slide covers the most fundamental rules that need to be observed. However, if you'd like, you can check the PSR 12 on your own. There is a link beneath the slide. I strongly recommend that you get yourself acquainted with these rules, because if you're creating new projects in PHP, it's highly recommended to use these rules for any code you possibly write. The advantage is that if everybody would use these rules, then all the PHP code would look the same, so nobody would actually have trouble reading it. It would be much more convenient for the readers. I have mentioned the usefulness of documentation comments, documentary comments, several times. For instance, we can use them to provide annotations or validation annotations for endpoints in front controller design. So there are many applications. Furthermore, they are very useful for the very purpose the name suggests, so for documenting the code, of course. There are rules how to write these, so there is a generic PSR 5 specification or recommendation that suggests how to write all the documentary comments in general, and also there is a PSR 19 which actually defines a list of valid tags that should be used in annotations. Tags like these, so tags are typically words, keywords prefixed with @, and these keywords are used for various purposes. In this case, for instance, they are used to document this function, so we know what type is the parameter of the function and what's the return type of this function. Yeah, of course, some of this information may be as well placed into the type hints. Actually, they should be placed also in the type hints. However, you may provide more elaborate information in these documentary comments, which can be used for further validation or documenting the code itself. At the end of this lecture, I would like to point out a few very useful tools, software tools and libraries that may be used for PHP code development. First, I would like to start with a linter. Actually, I would like to elaborate on that a little more. PHP is a dynamic interpreted language, which is very useful in some cases, but it holds some pitfalls. If we had a compiled language, the compiler would be kind enough to eliminate some types of errors like typos in the code. However, in PHP we don't have the luxury of compiling, that the code is immediately executed. So normally we would like to perform some checks before we deploy this code on the server. So before we give this code to the user, we would like to perform some checks that the code is actually at least syntactically valid. To perform these types of checks, we have various types of software. Most of these are called linters. Actually, this is not a specific of PHP. Linters are useful for other dynamic languages as well. For instance, in Python we have also many various linters that can be used. In PHP there are several state-of-the-art linters. There are two examples here. Mostly these libraries are directly integrated into your IDEs. For instance, if you are using Visual Studio Code, as I do, there are various plugins that you can just install within few clicks, and they will immediately allow you to check. They will immediately check your code and allow you to fix your errors before you deploy your code to the server. Even with linters, it's likely that from time to time a programmer makes a mistake, creates a bug in the code, so debugging is an essential part of the programmer's life. In the case of PHP, it's slightly more complicated, since the PHP code is normally executed at the server side, so it's executed in the response of the HTTP request, so we need somehow intercept these executions of code and handle all the necessary things like performing step-by-step debugging, checking out the environment, setting up breakpoints, etc., etc. For these purposes, there are several plugins into PHP itself. Perhaps the most well-known is the xdebug plugin. It's an extension which is introduced into the PHP module, and it provides an external API via socket, so you can connect to the xdebug itself via TCP connection, and the proper client of xdebug is able to communicate with this module, pause the execution of PHP, wait for the execution of PHP script, and everything else that's needed to be done in terms of debugging. Again, there are many useful plugins for various IDEs. Again, my favorite, Visual Studio Code, has direct xdebug client that handles the necessary communication both locally, so you can have the xdebug running on the local server inside your local Apache, for instance, or you can remotely access running instance of xdebug on your testing server, for instance. So both are possible, and it communicates pretty well. It shows you the breakpoints and everything in the code, so it's a very neat way how to debug PHP. It's even more simple to use with PHP CLI command line applications, so you can use it both for the web applications and for normal command line scripts without any problems. Usually it's better to take some precautions not to make any mistakes, at least not to let your bugs to get into the production code, so catch your bugs early in the development, and for that we need testing. Testing is one part of software development which is constantly underestimated, and the PHP and web applications are no different in this case. So I implore you, do test your code. It's very important, especially if this code goes to the production for the huge amount of users to be used. So it's very important that you catch your bugs before it gets to that. So in PHP there are many tools that can help you with that. Perhaps the well-known tool for testing is PHP Unit for unit testing and for continuous integration. Basically it does not differ too much from other types of testing. You basically write test cases and methods. Each test is a method in this test environment. So you basically write something that executes your endpoints or your functions, your methods, and then test asserts that should hold at the end of the execution of your code. For the testing, there is one thing that's very important, and they are mockups, meaning you need to mock a part of your application in order to let it give it appearance that it's functioning properly. In my opinion, the most difficult of mockups is the database mockup. So you should need create some sort of fake database. There are various techniques how to handle this. I have experience with Alice, for instance. Alice fixtures. Fixtures are kind of a code that allows you to type very small amounts of data which are immediately transformed into tables, and these tables are loaded into SQLite database, and your database system then mocks your database wrapper should mock all the database queries to access this SQLite instead of the regular normal SQL database. The tests are problematic since the tests are also written by the programmers, so often programmers fail or forget to test some specific part of the code. So normally it's a good idea to accompany your unit test with some other tools like static analysis tools. These tools analyze the PHP code without actually executing it, so they try to anticipate how the code will be executed, try to anticipate various inputs, and then try to detect things like unreachable parts of code, or try to identify invariants that will not hold under all circumstances, under all the input data. There are again several tools. This is a list of few of them. I have some experience with the first one, however most of them should work in a similar way. So basically you just execute this tool and give it all your PHP code, and this tool will actually process the code altogether without actually executing it, and try to identify potential errors. Sometimes it's necessary to provide some additional annotations in the code so these tools can work properly. So sometimes you need to, for instance, provide additional annotations beyond the limits of PHP, like providing the types of variables where needed, so that all the invariants in code can be checked correctly. However, this is a typically minor price to pay for the benefits of these tools. So I again recommend using these tools at least for larger projects in PHP. Finally, the ultimate tool that's very necessary for managing larger projects in PHP is a package manager. Perhaps the most often used manager for PHP is the Composer. It manages third-party libraries and tools, so it's very useful for installing those to your projects. It works as follows. It records all the necessary information into a JSON file in the root of your project. It has also some additional functions, like it can create a skeleton project for you. So for instance, if you call something like Composer create project and you provide a skeleton name, this is the vendor name, and this is the project name. This is the project name, this is the vendor name, and the type of the sandbox. So this is the template for the project which will be created. It will create all the necessary subdirectories, all the initial files, everything for you. So sometimes it's very useful to create your initial setup of the project. Then you can add additional requirements, additional dependencies of your project. So it will automatically link them into the Composer JSON file and automatically download them and install them in a specified directory. Without this approach, without this package manager, it would be very tedious to, let's say, manage all the dependencies between the projects, because sometimes if you just require one project, it might have some dependencies which needs to be installed as well. So to resolve all these dependencies, especially with different versions of all these dependencies, you need some software that handles all these things and all this stuff. So that's it. Thank you for your attendance. I would like to remind you that this was mainly an overview lecture, so I didn't dig into many details. Actually, that's your job to check out all the details in the PHP reference, to check out the PSR recommendations I pointed out to you, and I would like to recommend to check out all the PHP development tools I've pointed out it as well, because they might get useful, especially if you start writing code, starting write larger projects in the production. Finally, I would like to say that I haven't received any questions regarding the previous lecture so far, so for now we will keep the communication channel to be the emails. However, if there are more questions, if the stream of questions will, let's say, intensify, then we will set up some meeting. For instance, we can set up a Zoom meeting to handle all the necessary consultations if need be.